Welcome to another new video of interesting math problem on our channel Math Solutions for You. Please do like, share, comment, and don't forget to subscribe to our channel. This is a very simple looking quantitative comparison question on geometry that actually, as you'll see, is pretty misleading and is actually one of those harder questions that you can find in this particular category. So the question is given as follows. The length of diagonal of a rectangle is 14 units and its area is a square units. We are given two quantities. The first one, quantity A, is simply the area of the rectangle, and quantity B is given as 99. And then we're asked to determine what's the relationship between the two quantities. It's a very standard quantitative comparison, but it's a little bit tricky here, and I'll tell you why. So let's start with drawing out the rectangle. So we are given the length of the diagonal of this rectangle as 14, and let's call the two sides of the rectangle x and y. And then we know that the area of the rectangle will be simply the product of x and y. But we, of course, don't know individually what x and y are. But from the fact that the diagonal is 14, we can, from Pythagoras' theorem, write this: x squared plus y squared is equal to 14 squared, because we have a nice right angle triangle whose arms are x and y, the hypotenuse is 14. So we can write this from Pythagoras' theorem that x squared plus y squared is equal to 14 squared, and that makes x squared plus y squared equal to 196. So from this single equation we have, which states x squared plus y squared is equal to 196, we can't possibly solve for x and y. So at the first glance, it seems like the area can potentially take many different values, because x and y, there can be many different combinations of x and y that can satisfy x squared plus y squared is equal to 196. And this is where option D becomes tricky. So do we simply choose the relationship cannot be determined, because it seems like we cannot determine the area precisely. And this is where the problem or problems of this kind is a little bit hard and tricky, because one thing you have to consider before you rush to option D is whether from the given information you can establish some sort of bound on the area of the rectangle, right? And that's something that remains to be seen here before we rush to the conclusion that D is the correct choice. So we are given xy, we are given x squared plus y squared. So what is x squared plus y squared minus 2xy? Well, that's simply x minus y whole square. It's a basic algebraic formula, right? Now, we know x squared plus y squared is 196, and we know xy is the area of the rectangle. So we can write 196 minus 2a is equal to x minus y whole squared. Now, this is where establishing a bound becomes important, because one thing that we can do from this expression is we know that x minus y whole square should be always a positive quantity, right? At best, it can equal 0, but it should be always greater than equal to 0, because it's a square. And the square of a real quantity should be a positive number in general, right? The lowest value this can take is 0, and that's the case when x is equal to y. So this is an inequality we have now here, which helps put a bound on what value a can take. So we have 196 minus 2a greater than equal to 0, from which we can derive 196 is greater than equal to 2a, or 98 should be greater than equal to a. And the other way of writing the same thing is A less than equal to 98. So this helps establish a bound on what's the maximum possible value the area A can take. And it seems like it cannot take any value greater than 98. The maximum possible value the area of the rectangle can take is 98. So quantity B, being 99, has to be greater than quantity A. So the correct choice for this question will be actually option B. Quantity B is greater.